Welcome again. Myself Ved Prakash Saraswat. We will discuss the class 9 physics. In previous class, we were discussing about the acceleration, velocity, speed, about the basic concept of physics. Now, today we will discuss about the graphs. A graph between displacement and time graph, velocity time graph, and acceleration time graph. Very important topic to understand physics with the help of graph. So first we will start the displacement time graph. Okay, in this displacement time graph, let this is x-axis and this is y-axis. X, y, minus x and minus y. On x-axis we will take time. Time will be represented on x-axis in seconds, and on y-axis this is displacement. Now question comes, why we are taking time on x-axis? Why not displacement on x-axis? Time can be taken on y-axis also, but technically this is wrong. Because when we draw the graph, we have the two types of the physical quantities. One is dependent and other is independent. As per the norms of the graph, please listen to me carefully. As per norms of the graph, always independent quantities taken on x-axis, while dependent quantities taken on y-axis. When we represent the graph of time and displacement, time change by its own and displacement depend on time. So, this is time 0 here, this is 1 second, 2 second, 3 second, 4 second. I am simply taking sample and example. And let this is displacement. This is now let the meter. Suppose in meter, this is 2 meter, 4 meter, 6 meter, 8 meter, 10 meter, like this. Case 1. When the line of the graph is parallel to x-axis. This is graph. Displacement time graph. This is line of graph. What this line shows? It shows that already object was at a distance of 4 meter, and now time is changing, but value of displacement is not changing. Time is changing, but displacement is not changing. It means object is stationary. Object is stationary. Let any graph is showing like this, which is parallel to x-axis, and graph is between time and displacement. That object is showing. This is showing the object is stationary. One time of graph. Let graph 1. Graph 2. second type of graph. This is case 1. Let graph is like this. That I am going to draw this line some darker, like the dotted line. Suppose I am taking, so you can understand easily. This is line. It means time is changing and displacement is also changing. This graph is showing, graph number 2, this is showing that time is changing and displacement is also changing, and this is a straight line. It means change in displacement is uniform. Time is changing and displacement is also changing. It means object is moving with uniform velocity. But let this is one graph, straight line, this also straight line. In this case also, object is moving with the uniform velocity. So now I will tell you one more point. Let you are going to find the slope of this graph. New concept, slope. I hope in class 9th, class 8th also, you study in maths. What is slope? Slope is change in y upon change in x. I will tell our slope in detail. So, the slope of the graph, displacement time graph, always give us the velocity of an object. Okay, I will tell you how to find the slope. To find the slope, we are taking one example. One line is there. Displacement time graph. I am taking one point at this here and second point here. So join it on x-axis and on y-axis. That this is approximate at 3 and this is 4. One more, that this is 6 and it is at 8. How to find slope? So this is value of y. Coordinates are 3 and 4 and its coordinates are 8, so 6 and 8. 6 and 8. So change in y. So 8 minus 4 equal to 8 minus 4 upon change in x, 6 minus 3 equal to 4 upon 3. This is its velocity. So how to find slope and how to find velocity? If a graph between displacement and time is given by finding slope, and as the value of y, meter and second minus 1. Let one more case. One more graph is drawn like this. Then this is number 1 graph and this is number 2 graph. But again I am taking the 2 points, same point here and this one. This is at this point and there. We will find that value of y, change in y is more. This is 6 to much more, approximate 12. 6 to 12. So this is case 2. Case 2. Change in y equal to 12 upon change in x, again only 3, equal to 4 meter second minus 1. This is only 4 upon 3 meter second minus 1. It means that this angle is more, then velocity will be more. Angle is less, then velocity will be less. So how to analyze? By just observing the graphs, which object is moving faster and which object is moving slower, if a graph is between time and displacement. I hope you understood. Again I will tell, let the two graphs are drawn on the same scale. Graph is between time and displacement. The graph in which the angle is more, the velocity will be more. It means slope is more. Take two more examples. Graph again between time and displacement. The graph is parallel to x-axis. I had told all in advance that already that object is stationary. Check whether object is stationary or not. Let this is time t1, and this is like the time t2. Time t1, the displacement is d1, and time t2 also, displacement is d2, but there is no change in d2 and d1. So the slope equal to d2 minus d1 upon t2 minus t1. So d2 minus d1 both are equal. So 0 upon t2 minus t1 equal to 0. Slope is 0. Slope is 0. It means velocity is 0. One more case. Let graph is like this. It means ordinary object while moving and displacement was there. Okay. Now from this point displacement is negative. It means in this case object was going away. A object was going away and object is coming towards original point. Okay, like this we can analyze the graphs. Graph between displacement and time. One more type of graph. Let graph is like this. It means object is displacement is not uniform. Displacement is not uniform means velocity is not uniform. It means at the place to place its velocity will change, its slope will change. This is the graph between displacement and time. Now velocity time graph. Now again, velocity time graph. The time is on x-axis again, and velocity will be on y-axis. Time in seconds, and velocity in meter second minus 1. Now see again, when graph is parallel to x-axis, in that case time is changing but velocity is not changing. Means object is moving with uniform velocity. Object is moving with uniform velocity. This is case 1. Now case 2, let graph is drawn like this. it means time is changing and velocity also changing. This is uniformly accelerated motion. Means velocity increasing with time. Okay. Now Newton graphs acceleration and time graph. In this case, let line of graph is parallel to x-axis. It means uniformly accelerated motion. Means velocity of object is increasing with time. Okay, and let graph is drawn like this. Variable acceleration of x is increasing, or let graph is drawn like this. Again, variable acceleration. Means object is not moving with the uniform velocity, but sometimes its velocity increasing, sometimes velocity decreasing. This is also not uniform. Okay, so these are some graphs. I will discuss about the graphs later. Okay, now some details of the graphs and numerical based on the graph and some formulas, the three equations of motion we will derive in the next class. Thank you.